Hi friends, so today we are into our module on risk conscious operations management, and that means we are coming to the core of our subject because an explicit understanding is required. How do we have the interface from the risk module into our operational procedures, acts, and various technology development. So we will be discussing well the RCOM methodology what we have developed. There we call as integrated operational risk management, because we are trying to see collectively risk component and operation. Operation is basically meant its emphasis is there on deliverables while maintaining the safety. And safety is of course an overriding factor. So that is very tricky, and that's why an integrated framework was developed. Now to deal with this subject, it has been presented into 5 modules, like we have 5 lectures every module. One is we will discuss the background and introduction component, then integrated operation management approach, and then how this approach is extended to develop an integrated operation management system. And then there are some very specific aspects which are especially integral also, but then they were treated in one way. So like root cause analysis, it has been an inherent component of operational procedures, incident investigation, and then the failure precursor analysis. This is relatively a new component compared to the traditional techniques. And what role probabilistic risk assessment plays in this. And finally, we know the plant starts, then it has got an initial phase we call infant mortality in terms of PDF, and then we have useful period, and then we have plant is showing sign of aging. So then the refurbishment starts, because so aging is or life extension is a intuitively a integral component of operation, because after the refurbishment or aging management, the plant spring back to normal operation, and then start delivering for another 10 years, 20 years, 15 years, depending upon the plant and what are their goals and objectives. So we will see the 5 modules, and let us see what are the why we are first of all studying this subject. This subject is because after the plant is designed and put into the operation, this becomes a very important phase of almost 40 years, and its operation is should be smooth in terms of it should be event free or accident free, because every accident has got a big liability and consequences, so ensuring the plant operation for its deliverable, number 1, and number 2 for safety or minimal acceptable risk level, and then of course in design phase all these things are taken care of, all the provisions are there. So even if we do 95%, there are certain lessons they are learnt during operational phase of the plant, that we'll see as we approach and we discuss the various modules. And then the operation phase starts. So operation phase means smooth operation, and there are disruptions in between for maintenance management, and again plant comes back to its life and again start delivering, and this period typically is lasts for 40 years, 35 years, or maybe 45 years or 50 years. But then after that, the last phase, that is aging phase, comes there, and then it is required to shut down the plant on a temporary basis, and then finally incorporate the remove the it is a complete strategy, aging management, and then bring the plant back to normal operation. And then operation maintenance ecosystem has got its own characteristics. So that we will be seeing as and when we discuss the models and methods. And then the plant organizational infrastructure. The plant organizational infrastructure, and that includes human factor, that has got a impact on the plant operation, and there are built-in provisions like training, training, qualification, periodic requalification, and to ensure that the human factor is addressed properly through the plant operation. And of course, accident management is not a routine subject, but there are provisions in the plant to fight out most of the postulated initiating events, and that is how accident management, then we have emergency operating procedures. So this subject answer we would have got why we have this topic, and of course as part of this module we have been discussing various aspects, and now this is the core module. And this is a no-no situation. This is Fukushima 2011, and the earthquake in the water body, and then it manifested into a tsunami, and as I mentioned, there were safety provisions. There were 7-meter walls around the plant, but then the wave height was a little higher, and then there were some safety recommendations which were to be met. And then the power failure, station blackout condition, and finally it took its toll in terms of something like hydrogen buildup into the reactor cavity, and then finally the explosion, and it had a very long consequences. Now the point I am trying to make here is the accidents do not have local, especially many accidents, they do not have local effect, they have widespread effect, so operation becomes the most important phase of any technology that we have. It starts from energy system to, it might go to transportation, railways, aviation, space, everything. So this needs very high degree of commitment and provisions. Now, we see that plant should operate reliably, and it should meet it's a deliverable. If it is a electrical station, then it should deliver the power supply uninterrupted to the extent possible. Okay, but that doesn't mean that whatever comes and we don't shut down the plant for any reason. Safety is an overriding factor. This is in perpetuity. This particular you can say paradigm should be maintained and should be respected. And it is being respected. That's why we see there are many industries, they are maintaining very high record of safety and all that. And then the safety spirit is implemented in the plant, like it's not only at talking level, it is basically a document called technical specification, which stipulates the condition condition that is called limiting condition for operation. Then it is limits on parameter, and the topmost priority is safety limits, and all these should not be violated. In any case, if these things get violated, then it requires a regulatory review. Plant should be in the shutdown condition, as regulator compliance has to be met, whatever the directives are there, and once the regulators are satisfied, then only plant can come back to the operation. And then safety and security risk matrix. Traditionally we had only safety matrix, but nowadays last 2 or 3 decades, this security metrics has been also playing. So these two together, that means security risk and safety risk, this should be met at the safety level for any activity in any sector, whether it comes to in energy sector, hydel sector, or any sector. Major factor in operation ecosystems are ensuring plant normal operation. Yes, it is one of the objective, because it is a bottom line. It meets the bottom line or objective of the plant for which it was built, and then the spectrum is there from normal operation to deviation to accident event, and then there are so many things I'll discuss in details. So these are the factors that are there that form plant operation. This module will present an integrated approach. Integrated I am saying because many techniques and technologies have been integrated or requires integration to have this ORCOM approach for risk and reliability. Okay, now why we are working on this? The traditional approach to safety, conversely speaking, or risk is a great. It was based on the deterministic philosophy, but then the deterministic philosophy finally it got. It is also innovations are taking place in the technology, and now it has gone to the other level, that is called where defense in depth and other mechanisms are there, right from plant design, operation, and maintenance. And so this is the integral feature of the traditional deterministic approach, and of course conservative margins and all. So essentially they are characterized. We have discussed many times during this course. The plant technique specification also we have talked about it. It is like a safety book that needs to be respected in all the condition, and all the stipulations should be followed. If any deviation is there, then it should be taken, and due consideration should be given, not in terms of corrective action, but review at peer level and all that. That might include even regulatory provisions. That does include the regulatory provisions. Role of operating organization in the final responsibility of the safety of the plant. Okay, even though we have a regulatory body and all that, this is the safety responsibility lies with the operating organization. Okay, and then the regulatory bodies oversees the functions actually of the plant through meetings, through visits, through walk down, and then periodic audits and all that. So this is how a safety framework works. Now, role of human in operation is, we have been talking about it, human operation ecosystem is human interaction intensive. So it is not that the humans are running around and all that. It requires a supervision, surveillance, and manning of the plant 24/7. Of course, new systems are being developed, and it is expected that there the continuous and perpetual, they are called small modular reactor or something technologies, where these kind of things may or may not be required, or not required the way it is done now. Now, risk management is a conscious effort, that includes risk identification, reduction, and corrective mechanism implementation. And how we do it? We do it through regular surveillance, monitoring, control room is manned, and inspection, maintenance, repairs, and tracking and compliance to follow at the safety level. Then documentation, yes, it is a very important component. We have any complex system will have its own design document, engineering drawings, then it emergency operating procedures, and then safety manuals are there. And apart from that, there is a robust training program. Plant incidents are analyzed in detail and reports are submitted as part of safety, and if required it is submitted to the because if it is safety significant or risk significant, it has to go to the regulator and it should get the oversight this thing input. Review and regulations, yes, these are very independent part of the operating organization. And now let us see what are the things which form the part of the technical specification, because it is the important document in the control room of any plant, where if any deviations are there, of course shift engineers are trained, but he has to verbatim match the situation looking at the document. It could be computerized also, it could be hard copy also, but scenario mapping is required, what is going on in the plant if any deviations is there. So, the first part which is safety limits, the highest component of the safety, it should not be violated in any case. If it violates, then plant is shut down, and then the limits are reviewed by the regulators, and then finally depending on the corrective mechanisms and all, recommendation and oversight, testing and all, and finally plant can come back to the operation. It does not mean plant has gone into the accident condition. These are the preventive provisions in the plant. They should not touch the safety limits. Then safety parameter settings, typically operational settings, and these things remain, and the plant operating ecosystem is under these settings. If any setting goes up beyond its set parameter, then action should be taken. Limiting condition for operation, these are the condition. If something happens and the safety margin appears to be compromised, then action should be taken. Surveillance and test schedules, and then operating organizational structure, condition for regulatory compliance, and role or responsibilities. Now there are some trends in you can say current trend or new dimension. Like earlier we had a deterministic approach, now that has evolved into the best estimate approach. Why? Because now there are data that are available, so we can evaluate the conservative portion of margin that we had with us, and using the probabilistic consideration, these aspects are revisited, and then finally a new definition of margin in terms of best estimate approach has been developed. Now we can see safety and security. Both traditionally it was only safety that the plants were designed, modeled, and and operated. Now we have security aspects. And then the third development is because data is available and it should be utilized, the probabilistic risk assessment has been playing a role, and it has entered into the plant operation and regulation system. In regulation it has entered as a risk informed approach in support of decision. In operation it is basically to have a relook at our activities, whether we are very conservative, and accordingly probabilistically they are evaluated as part of risk informed or risk based approach, and corrective measures are taken if the margins are of course available. And then modern training has also improved. Well, the limit of level 1 PRA has so how PRA has been playing role for complex systems, especially nuclear plants. Almost 430 plus nuclear plants are operating world over, and for most of the plant level 1 PRA has been there. So that vindicates the applicability of this method and acceptability of this method also. For many plants, level 2 PRA has also been developed. Level 2 PRA means now we are talking about some deviation has taken place, and now the consequences are being evaluated inside the containment. And level 3 PRA means it is the accident consequences are being evaluated in the plant boundary or in the public domain. And of course, the ultimate objective is that the public areas plant consequences should not reach. So that is how this level 3 PRA is performed. And then modern training methods also have improved. Now we have computers to our benefit, so a lot of learning capabilities have increased. We have nuclear plant simulator. In fact, simulator they are part of aviation, nuclear process, many plants. So simulators are have enhanced. Rather appears to be enhancing the training efficiency because the live sessions that are performed in simulator room without affecting the actual plant provides enhanced opportunity for learning and training. And of course, some experiments also can be done, so that has got additional effect of training. Now, use of computers and networking, yes, the risk monitors are becoming slowly the part of control room or behind the control room activity, wherever decisions, risk informs decision is reasonably accepted model technology. In service inspection was there earlier, and now it is called risk based in service inspection, because PSA or PRA insights are available, and these insights are not only insight, models are used to structure the risk based inspection program. Control room logics, earlier it used to be hardware logics, and now the logics have been being transformed from wall based to solid state logic, and now digital system and video based systems are there. Test and maintenance programs are using PRA framework for risk based test and maintenance management are being developed. And then operator information, especially for emergency condition, it is one of the because when the emergency situation occurs, the control room is flooded with the information, and in that case, if the online signals are available to the computer and there is a intelligent tool operating on that computer, then operator can be presented with the information what is the status of the plant and what action can be taken if the situations are deviating from normal conditions. And in this direction, the international organization, one of the organizations is International Atomic Energy Agency, and other one is the European Nuclear Energy Agency. They have been playing a very important role for developing the safety culture. This is one of the most you can say not latest, but very recent development that has happened, because the objective of this safety culture is what is being conceived in the documents provided in the plant, it should become part of the culture, and that is where the safety benefits can be accrued. It should go into the conscience of the consciousness of the people who are operating the plant, right from management to middle management to manning shift people to grassroots level people. Everything should go. Then only even a small, if I have to give even a small foul smell in the area should tell me there is something wrong, because I have been going to the plant areas and then one day it happens, or some traces of water on the floor, that should tell me something, because I cannot ignore till I find a reason. So I should be conscious about it, and same thing is applied with even if a small information that is available in terms of some signal, audio or visual signal, it should be analyzed properly, and that goes into planning and procurement, plant supervision, maintenance, plant modification, training, documentation, regulatory compliance. In all these things it follows, and finally it is the quality assurance of each activity being done. Quality documents are available. In fact, for PRA model of the plant, there are quality documents which tells you what is the metrics one has to follow. If we are deviating that metrics for some reason or whatever causes, we have to document that, and then the peer review person can tell what is the quality of my risk assessment study itself, and that helps a lot because it has been reviewed by the independent body. Now, additional generic observations are there. There is a appreciation of individual and organizational level that human factor development need enhanced attention. Okay, because we cannot deny this fact that from 50% to 90%, human factor is one of the major component in any accident. So one of the major insights from the safety review or PRA review has been that common cause failure is one of the major contributor to the accidents, and if that common cause failure has to be is human factor, then probably it becomes more serious. So these are the lessons that we have been learning over the years, and sharing of experience learning at the plant level, at the national level, at the international level, because one incident in one place everybody can have a lesson from this, and we can have a corrective mechanism. So that is the ecosystem which has been developed for many industries, and then based on this accumulated experience and reviews and critical reviews and all, now there is a big development that is going on, especially in nuclear sector. It is called small modular reactor, SMRs are being developed. Instead of mega plants, develop the reactor in such a way that the component system, they are available in modules, and they should be of having very if present plants are about 1000 plus megawatt capacity, this will be with a small capacity, and that will reflect into its inventory also. So these things, and then human factor, which is the cause of concern is on today, this can be reduced because there will be passive and inherent feature. The fuel matrix itself will be inherently safe, and if any phenomena is unsafe phenomena is growing, then it will be self automatically controlled because of the factor which are being developed as a consequences of the phenomena itself, like temperature. It can reduce the effect, and the plant doesn't go into the accident mode. So these are the modern methods that are being developed, and this is really the outcome of operating experience and design experience of over the years that we have.